next going to rewrite the query we just wrote, but here we're going to be using the word exist instead. And exist also goes into the where statement. And then what we do with exist is that it evaluates whether the subquery returns any rows. If the result set from the subquery is empty, then exist returns false. But if there is some rows in the result query from the subquery, then exist returns true. So here we're not returning a value to then compare to a field in the outer query. So we have to set up some sort of relationship between the outer query in this subquery. And how we do that instead is to use a correlated query. And the correlated query is a subquery that takes one of the outer query's fields as a value inside the query. And what we end up doing is we end up running the subquery one time for each value that's passed into it. So if we have 100 rows in the outer query, then we're going to be running the subquery 100 times, one time for each of those rows, or once for each of the values that are being passed into the subquery. But let's go ahead and rewrite the code. So here I copy and pasted the code from before. By the way, I fixed this. I didn't actually fix it. It's just a novelty here. It's a novelty goods suppliers. And let's fix some of the indentions here. All right, so now we fixed the things from the prior one. But what we're now going to do is we're going to use this general syntax here and just rewrite this as a exist query. I also said earlier that we somehow need to pass a value into this subquery here. So what is it that I want to evaluate? Well, I'm going to be evaluating if a specific value in the supplier ID up here in the supplier table is equal to a row in the subquery, and that row is a toy supplier and novelty goods supplier, then I'm going to return a row. So let me go ahead and show what that looks like, and then I will explain what that does in a little bit more detail. So I'm going to add an and here. And here I'm going to say A supplier ID equals B supplier ID. So what this now does, it takes the supplier ID from the outer query, so from the supplier table, and then compares the supplier ID to the supplier ID from the supplier category membership table. What really happens then is that when I run the outer query, the first row from the supplier table, we're going to take that supplier ID and then say that supplier ID 1, for example. Then when I run the rest of this thing, let's ignore and for now. This is going to return a list or a bunch of rows that have toy supplier or novelty goods supplier in the supplier category name. If one of those rows has a supplier ID that's equal to 1, then I'm going to return a row from here. Or at least one, it could be many. It could actually be many because a single supplier could potentially have many entries. It could be both a toy supplier and a novelty goods supplier, but it's returning some sort of row. All right, let's continue on with the example. If this then instead is in the second row, because I'm going to pass in for every row, I'm going to pass in the supplier ID down here. So say the second row has supplier ID 2. Now again, I'm going to get my result set with a bunch of toy suppliers and novelty goods suppliers. I'm then going to see if any of those rows have a supplier ID that's equal to 2. If it does, I am now going to return some sort of result set from this. If it doesn't, so let's say that there is no supplier ID from this query here, from the subquery that has the supplier ID 2. There is no such supplier ID. Then this AND statement of part of the where is going to evaluate to false, and I'm not returning any rows. And therefore the exist gets an empty result set and returns false. So then we get nothing for that specific row. So if we go ahead and run this, we should get the same results that we had before. All right, so I said before that I prefer joins. Well, I think these are kind of complex to think about. Just simply that I need to pass in a bunch of single values and then those evaluated, and the in statement similarly, I got to think about what does this subquery return. There's some sort of list of values, and then that list is compared to the outer query's supplier ID. I think that's difficult to think about for some reason, but I don't think joins are very difficult to think about. Maybe it's because I've used joins a lot more. But again, some people like exist, some people like in, some people like joins, some people like two of those, or all three for that matter. All right, so I'm going to rewrite this anyway as a join statement instead. So I'm going to delete those, and then I'm going to type join here. And then I already have a join here, but I need an on for the one above. And I actually have my on down here. I'm just going to copy this up to here, add the keyword on, and then we keep this where statement. Delete this, and that ends the query right there. All right, so let's take a look at this. So here I'm simply saying take the supplier table, join it with supplier category membership table based on the supplier ID, then join this, with a supplier category table based on supplier category ID from the supplier category membership table and from the supplier category table. Then from the supplier category table, compare the rows in there in the data, and if any of those rows is toy supplier, novelty goods supplier, then return those rows. So essentially what I'm doing is I'm getting for each supplier in the supplier table, I'm finding out what their supplier category name is. And if that supplier's supplier category name is either toy supplier or novelty goods supplier, then keep that row. And it's that simple. So when I run this, I should get the same result. I got some syntax error here. I got something wrong near the ending parenthesis. And the problem is I have an extra ending parenthesis. That was the ending parenthesis for the subqueries. I need to delete, and then it should run. And now I get the same results set again. One nice thing here is that instead of just returning this hard-coded string, now I have access to this actual value. So I can actually just simply print this value instead, or select this value. And now I will get that as output. Because I'm joining, I have access to all the different columns from all these different tables. And notice here now, I have one of these 5. Those are toy suppliers, the other 4 are novelty goods supplier. And that I couldn't get from Exist, and we didn't talk about that, but I don't have access to that in Exist either. You can pass a value in from here into Exist, but I can't pass a value back because all it is doing is evaluating if this query returns a row or not. It doesn't actually return anything into here, so I can't go that way either. And we already talked about in. So which one should you be using? Well, the performance difference between in, exist, and join is usually very small, but there are some differences sometimes, and it depends on the specific context. When I've been evaluating these things and reading other people what they have evaluated, I tend to think join wins, but that's probably me doing some sort of confirmation bias here. So I would have, if performance is important and you're running a lot of data, we'll compare the 3 to see which one is the best. If performance is not a consideration, you're not running the query enough times, so it's not big enough of a data set, then go with whatever one you're more comfortable with. Sometimes using join or using exist or in might make it easy to read the code. For me, it's rare that in or exist is easier to read than joins, but that might be different for other people. One important thing though is that join provides a lot more flexibility. You not only get access to all the columns in all the tables that you're joining, but you can also do things like decide whether this should be left join, inner join, right join,